Hi everyone, it's Rohan this side. In this video, I'm going to show you how to solve this entire paper of Pure Mathematics 3 that came in the Cambridge examinations during their February-March 2025 sessions. And this time, my approach is slightly different as compared to what I have been doing in the October-November 2024 series. That is, this time, I'm already having the answers written on the screen, if you can see. So I'm going to first go through the question. I'm going to hide the solution, but then I'm going to tell you how to go through these particular steps, and then I'll explain you how I have done it over here. So in this case, I can save a lot of time for the video so that you don't really need to wait until I explain everything in detail. So yeah, in the October-November 2024 sessions, I didn't write anything beforehand. I was explaining while I was writing. So yeah, whatever is the best method that you find, guys, just let me know in the comments so that from the next sessions, I'll make sure to create the work solutions based on that. Okay, guys? And yeah, don't forget to click on like and subscribe and also share it to the friends whom you think this video might be useful. So yes, let's get started. Now for the first question, we are asked to solve this equation and give our final answer correct to 4 decimal places. And over here, there are two majority of the skills that will be tested. First is the algebra and the second is how do you manipulate this logarithmic term. So over here, you will need to know two of the rules of natural logarithm. The first one is ln of x is equals to k, where k is some kind of a number. If you want to get rid of ln, what you need to do? You will need to introduce e as the base on both the sides so that e to the power of ln of x becomes x, and on the right hand side it will be just e to the power of k. That's the first rule you need to know. Which is the second rule? The second rule is if you are having e to the power of x is equals to k, and if you want to get rid of this e and want to get x in the bottom, then the rule is you just apply ln on both the sides. So I'll have ln over here and ln over here as well. So now this will become ln of e is 1, and then I can use the power rule of logarithm to bring x down in front of the logarithm so that it becomes x ln e, but ln e is 1. So it is just x is equals to ln e. So if you are aware about both of these rules, then you can solve this question very comfortably. So let me show you how to solve this one. So to start with, I have just sent this 3 to the right hand side so that this becomes in the format of ln of something is equals to k, so that I can have e as the base on both the sides to remove this ln. So in the next step, you will see that ln is gone now and you are left with 1 minus e to the power of minus 2x is equals to e to the power of negative 3. After this, it's all about how you can make e to the power of minus 2x the subject. So I'm just going to send this to the right hand side and bring e power of minus 3 to the left hand side and say that e to the power of minus 2x is now equal to 1 minus e to the power of negative 3. Now, how do you make x the subject? For this, you will need to bring x from the power to the bottom. And for that, I'll need to use ln so that ln e becomes 1. This is the second rule that I have taught you before starting this solution. So I'm going to bring ln on both the sides. And ln of e becomes 1 and minus 2x comes in the bottom. And then on the right hand side, I'm having ln of 1 minus e to the power of negative 3. After that, it's just about making x the subject of formula and giving your final answer correct to 4 decimal places. And that is how you solve the first question. Now for the second question, we are given an implicit equation for which we have to find the gradient of the curve at the point where x is equal to 0. So now if you notice, we are having the x coordinate as 0, but we don't know what is our y coordinate. And because of that, we'll first need to figure out what is our y coordinate when x is 0. Once we are having both the points x comma y, I can differentiate this implicit equation with respect to x. And in doing so, I'll be having the equation of a gradient both in terms of x and y. And then I'm going to substitute that value of x and y into that equation and get the value of the gradient at those x and y coordinates. So let me show you how I have done this. So to start with, I have figured out what is the value of y when x is equal to 0 by simply putting this x and this x over here as 0. I'll be left with ln of 2y is equal to 1 to start with, and then to remove this e, I'm going to introduce e on both the sides as the base, so that I can have e to the power of ln 2y is equals to 2y, and then e to the power of 1 is equals to e. And that is how I get the y coordinate as half e when x is equal to 0. So now that we are having the coordinates x and y at which we are trying to figure out the gradient, I need to now find the what is the equation of the gradient. I can do this by differentiating this implicit equation with respect to x. Now please note that in doing this, whenever I'm going to differentiate x with respect to x, it is going to be a normal thing. But then whenever I'm going to differentiate y with respect to x, So let's say, for example, if I want to differentiate my y square, it is going to be normally 2y. But then because it is with respect to x, I'll also need to multiply this with dy dx or simply y dash. So let me show you how I have differentiated this implicit function. For the people who are already good with implicit differentiation, this should be a piece of cake for you. But for the students who are not really well versed with this, let me show you how to do this. So for the first term, as I can see that x and y square are multiplied with each other, I'm going to use product rule of the differentiation, which states that if there are two things multiplied with each other and if you want to take its derivative, you do u dash into v plus v dash into u. So it's the derivative of the first term times the v, which is y square, plus derivative of second term times the u, which is x in this case. So over here, if I'm going to implement this, you can see that derivative of x is 1, and then into y square will become just 1 into y square, which is y square. Then plus derivative of the second term, y square derivative, which I just showed you a moment ago, is going to become 2y y dash. And then u is x over here for us, and that is how I get 2xy times y dash. So this part is coming just from the differentiation of the xy square. And then if I talk about the derivative of the term with respect to ln, what do we do over here? So if we are having ln of anything, literally anything, then if you want to take derivative of this, it will simply become 1 divided by that anything that we have written times the derivative of that anything. And that is what I have done over here. Because x plus 2y is that anything that we are talking about over here. So I'm going to get 1 over x plus 2y times the derivative of x plus 2y. Please note that because we are differentiating with respect to x, whenever you're going to differentiate 2y, it is going to become 2. But then because it's also with respect to x, it's going to become 2y dash. That is why I get this 2y dash over here. And the derivative of x with respect to x is simply 1. And on the right hand side, because the derivative of a constant is always 0, that is how I'm getting 0 on the right hand side. So yes, that is how you differentiate this implicit function with respect to x. Now that I'm having the equation of the gradient and also the points at which I have to find the gradient, the next step is just to substitute the value of x and y in this equation and then just figure out what is my y dash. So for that, a lot of students might just say that let make y dash the subject of formula. But in my case, what I'm going to do is I'm just going to substitute y and x directly without making y dash the formula. It is time saving and we can get to the answer in a much more quicker way. So yes, let's substitute x is equal to 0, y is equal to half a in this equation and make y dash the subject. So after substituting the values of x and y, I'll be ending up getting this equation. And over here, I now just need to make y dash the subject of formula so that I can find the gradient at this given coordinates. And in doing this, I can use the way that I want because it's mathematics. It has its own beauty of solving the same kind of question in different ways. So depending on your practice level, you can make y dash the subject of formula. Over here, what I have done is I first of all sent e square by 4 to the right hand side. And then slowly one by one, I'm taking e to the right side, then 1 to the right side, and then 2 to the right side. That is how I get my y dash. After this, I'm simplifying it. I'm having the common denominator of 2 over here. So this 2 gets multiplied with the 4 and also get distributed over here. And after that, I'm taking the LCM over here to get 8 as the common denominator. And that is how I'll be getting my final value of the gradient at the given point 0, half e. Moving on to the third question, we are having a shaded region on the Argand diagram that is representing the complex number z that are defined by two inequalities. Now these two inequalities, if you can see over here, one is coming from the circle and then one is coming from the straight line. And over here, the shaded region is bounded by the circle and the line, as I mentioned, that is parallel to the x-axis. And this, the boundaries of the shaded region, that is this part and this part, are included in the shaded region, which means that in the inequality that we are trying to figure out that represents this shaded region, the inequalities will be inclusive, which means that if I'm using less than or greater than sign, I'll need to use less than equal to or greater than equal to even include the points that are present on the boundaries of the shaded region. So how are you going to do the first part? Well, for this one, you just need to know what is the equation of the circle, what is the standard way of writing the equation of the circle, and how do you define this line over here that is parallel to the x-axis. Let me talk about the circle first. Whenever you need to define the circle in the Argand diagram, the formula is modulus of z minus the center points is equals to r, which is the radius. So these are going to define all the points that is present on the circumference of the circle. But now if you want to define the points that are present inside of the circle, you will need to use less than equal to r. It defines all the points which are not just on the circumference, but also inside the circle. So over here, because I know that the center point is minus 2 plus I, so C is going to become minus 2 plus I. And the radius, if you can see, it is going to be 1, 2, and 3. And therefore, the equation of the circle that we are going to get in terms of inequality is going to become, let me show you, it is Z minus 2 plus I, which is the center, less than equal to 3. And then now let's talk about this line that is defined over here. Because we can see that this line is parallel to the x-axis, which is just defining the points on the imaginary axis, it says that no matter whatever is the value of x, my y value will always be negative I, which indicates what? This indicates the line on the imaginary axis, which is always less than equal to minus 1. If I say greater than equal to minus 1, it will represent the above points. Less than will indicate all the points that are below minus I. That will be minus 2 or minus 3, so on and so forth. And therefore, the second inequality that we are going to get over here is what exactly I have written over here, if I can show it to you. So yes, that is how you do the first part. Now let's move on to the second part. It says that find the greatest value of the modulus of z for the points in this region. So where is the greatest value of the modulus of z? First of all, you need to understand that where exactly the z lies in this region. So obviously, because we have defined in the first part that z is lying anywhere in this region, including the boundaries. And on top of this, you also need to understand the meaning of what is the modulus of z. So modulus of z is nothing but the distance from the origin of any complex number sitting inside this shaded region or on the boundaries. So what is the greatest value of the modulus of z? It's the greatest distance from the origin to any points in this shaded region. So clearly you can see that it's this point over here which is going to have the maximum distance from the origin. So you just need to figure out what are the coordinates over here. And then maybe you can use the distance between the 2 points formula or directly use the formula of how do you find the complex numbers modulus. And then that's it, you are done with this whole part. So the question is, how do you find out the coordinates of this particular point? Well, the y coordinate is pretty straightforward. It is just minus 1, or you can also call it as minus I. But if you're doing it with the coordinate geometry, you can call it as minus 1. And then for the x coordinate, you can see that here it is 2. But then you are still left with this much amount of path that you need to identify. This is unknown. But we also know that this value is going to be 2 because from minus I to 0 is 1 and 0 to I is 2. And because I know that this point is lying on the circumference of the circle, so the distance from the center to that circumference is going to be 3. So now applying the Pythagoras, I can say that square root of 3 square minus 2 square is going to be the value over here, which is simply square root of 5. So now that I know that this is my root 5 and this is 2, the x coordinate over here is simply going to become minus 2 minus root 5, minus 2 minus root 5. And now you simply need to identify what is the distance between these 2 points. It is just the square root of minus 2 minus root 5 square plus minus 1 whole square. And that value will be the final answer of this part. Let me show you how I have done this. So as you can see that there are no extra steps that I have taken apart from what I have already explained on the diagram. And therefore you are going to get all the 3 marks if you are going to have all the proper workings shown on the diagram. Over here I have just redrawn everything to look it in a much more better way. And therefore over here I have just implemented that the greatest value of the model of z is equal to this. So here's some markings on the diagram as kind of a proof of how we got to this conclusion is required to score all the 3 marks over here. And then the final value of the modulus of z will be coming out to this. So yeah, that is how you solve the part B. And now let's move on to the next question. We are going to first express the given equation as a quadratic equation in 10x first of all. And then we are going to solve that 10x equation for which the values of x must lie in between 0 to 180 degrees. So the only concept you should be aware about over here is how do you convert cot x to 10x, that is simply 1 by 10x. And then you should be aware about the formula of tan of a minus b. You can find this directly from your formula booklet. It's just going to become tan a minus tan b over 1 plus tan a tan b. If you're aware about both of these formulas, then it's just about solving the algebra and get the equation in terms of tan. And then you can solve that quadratic and figure out the values of x, just how we do it in AS level. So let me show you how to do this one. So to start with, I've simply copied down this equation from the question. Then on the left hand side, I've implemented the formula of tan of a minus b. And on the right hand side, I've expressed my cot x in terms of tan x. Just note that the tan of 60 I've directly taken from the calci as, and I'm writing over here as root 3. After this, I'm going to have a cross multiplication over here. And I'm going to simplify that by opening the brackets. So 10x into 10x becomes 10 square x, then minus root 3 10x. And then on the right hand side is 2 plus 2 root 3 10x. And then I'm just going to make this as a quadratic in terms of 10. So it is going to become 10 square. Then minus root 3 10x minus 2 root 3 10x. I know that minus is a common factor. So minus of root 3 plus 2 root 3 into 10x will be the term in 10x. Then this 2 also goes to the left hand side, becomes minus 2 is equal to 0. Now that it's a quadratic in terms of time, I can use the quadratic formula to solve it further. And that is exactly what I've done in the next step. If you can see, I'm implementing minus b plus minus square root of b square minus 4ac divided by 2a. And then I'm just going to plug in these values in the calc, or the easier ways, just use the quadratic solver in your calculator if it's possible, and pass the value of a as 1, b as minus root 3 plus 2 root 3, and then c as minus 2. And directly you can copy paste the answer from your calculator and write it over here. That is exactly what I've done. Now, because I'm having 10x equals to a negative value or a 10x is equal to a positive value, and I need to find out the values of x in between 0 to 180 degrees, I'm going to do it step by step, first for the left side and then for the right hand side. I'm going to use cast tool over here that we have learned in the AS level. I know that my 10x is negative in the second quadrant in between 0 to 180. It is also negative in my fourth quadrant, but we are not having x expanding to that fourth quadrant. And that is why there is only one solution I'll be getting from 10x is equals to a negative value, which is I'll first figure out what is this base angle. I can find that base angle just by taking 10 inverse of this positive value, not the negative. It is always the positive value. So I'm taking 10 inverse of that positive value to get that base angle. And then from 180, I'm getting rid of that base angle to get my theta 1. And for over here on the right hand side, because I know that 10 is positive, my 10 is positive in the first quadrant and the third quadrant. Now, because the domain is restricted for the solutions being 0 to 180, I cannot go beyond 180. That is, I cannot go beyond second quadrant. So the only one solution over here will be this one, which is just the 10 inverse of 5.55611. And in solving this, the final answers over here will be 79.8 and 160.2 degrees, correct to one decimal places for the given domain. Now the next question is pretty repetitive, coming from the complex numbers. That is, how do you find out the square roots of a complex number? And what is the ideal way of doing this kind of questions? We start with taking the square root of the given complex number and say that we have to express this in the format of x plus iy. So how do you get this x and y in the exact form, that is without the decimals? The starting point is to square on both the sides so that you get minus 4 plus 6 root 5i is equal to x plus iy the whole square. Now if you expand this, you will be getting a real part and then the imaginary part. I'll equate the real part with the negative 4 and I'll equate the imaginary part with 6 root 5. And then I'll be having two different equations for the two unknowns x and y. After that, I'll just need to do the substitutions and solve for x and y. That is the ideal approach that we take for these kind of questions. So yeah, let me show you how I have done this. So here is the starting point that I was talking about. And on the right hand side, I'm going to expand this bracket and I'm going to end up getting this one. And after this, I'm going to say that x square minus y square is a real part. So it's going to be equal to minus 4. And then 2xy, because it's an imaginary part, it will be equal to 6 root 5. And that is what you can see I have done in the next step. And then I'm going to make y as the subject of formula. You can also make x the subject of formula. Regardless of that, you will be getting a correct answer. Over here, I'm going to get y is equals to 6 root 5 over 2x, and then 2 and 6 cancels out to get 3, and therefore y is equals to 3 root 5 over x. Now I'll need to take this y and substitute it over here, and in doing this, I'm going to end up getting x square is as it is, then y square will become 3 root 5 square is 45, that is why I'm getting 45 on the top, and x square is going to be x square is equals to negative 4. After this, I'm going to multiply my x square on both the sides so that I'm going to end up with x to the power of 4. Then this minus 4x square will come to the left side to become positive 4x square. And then over here, minus 45 is remaining because x square gets cancelled out when we multiply this term with the x square. And this is equal to 0. After this is a hidden quadratic expression that you can see. Over here, instead of substituting u is equal to x square, I am just doing it orally over here. I'm not doing the substitution. But let's say if you want to say that u is equal to x square and then say it is u square plus 4u minus 45, then you first find for u and then for x square. It's just the same thing. I'm not doing the substitution over here. So just by using the calc, by substituting the values of a as 1, b as 4, c as minus 45, I got the values as minus 9 and 5, if I can show it to you. So minus 9 and 5 is what Kelsey showed me, from which I'm making the factors over here, that x square plus 9 and x square minus 5 will be the factors for this given expression. And from here I can say that x square minus 9 cannot be solved, like x square is equal to minus 9 cannot be solved because we cannot take square root of a negative number. And from here, I'll be just getting the solutions as x is equals to plus minus root 5. And now that I'm having the values of x, I can substitute it over here to find the respective values of y. And that is the final thing that I'm doing over here, that when x is equals to positive root 5, y is equal to 3. When x is equals to negative root 5, my y will be negative 3. And therefore, I can conclude this statement that square root of this given complex number is equals to plus minus square root of 5 plus 3i. So if you open this, let's say with a positive sign, it's going to be plus 5 plus 3i. So it's this case. And if you open it with a negative sign, it will become negative 5, negative root 5, negative 3i, which is coming from the second case. So yes, that is how we solve this one. Now for the sixth question, we are given the differential equation which we need to solve and obtain the expression for x in terms of theta. And we are also having this information that when theta is equal to 0, x is equal to 5. We'll utilize this information to find out the integration constant in the process of solving the differential equation. So let's see how we can solve this. Now there are certain things that you need to keep in mind that is always going to repeat whenever you are trying to solve a question on solving a differential equation. The first step would be to separate the variables. Over here you can see that all of my x variables are on the left hand side and the theta variables are on the right hand side. The second step is to start integrating on each side. Then the third step is, once you are done with the integration, you are going to have an integration constant. You're going to find out what is the value of that integration constant by using this information. Once you are done with that, you're going to just obtain your final expression in which x will be your subject of formula, which will be in terms of theta. So that is the whole process. So as we are already done with the first step, that is separating the variables, and about to start with the integration, now let me show you how to integrate first of all the left side and then how you can integrate the right side. Let's talk first of all about the left hand side. For this, I know that it's already in the format of integration of 1 over ax plus b. And what is the integration of this? It is going to become ln of the whole bottom part, that is ax plus b, divided by the differentiation of the inner part, which is going to be a plus c, obviously. And then how do you integrate the right hand side? You know that whenever we are having a power of 2 for cos or sine, we use the formula of cos 2x. So let me first of all write the formula of cos 2x over here for you. So it's going to become cos 2 theta is equals to 1 minus 2 sine square theta. So in this case, let's normally, if we have to integrate sine square theta, we just make sine square theta the subject of formula in this equation, and then we can integrate with respect to cos. That is the simple process that we know. But over here, if you can see there is 2 theta, the idea is very simple. I'm just going to multiply all of my angles in this equation by 2. So this becomes 2 theta, and then this becomes 4 theta. And now if I just make sine square 2 theta the subject of formula, it's going to become sine square 2 theta. If I shift it to the left hand side, I'm going to get 1 minus cos 4 theta whole divided by 2. Or I can just say that this is multiplied by half, the one and the same thing. So if I have to integrate the left hand side, it's same as integrating the right hand side. And then if you're going to do that with respect to theta, you're going to get some kind of an answer. What is the integration of 1? It is going to be theta. What is the integration of cos theta? It is going to be sine theta. So it is going to be sine 4 theta divided by 4. And then don't forget, we also have a half. So this is going to become theta by 2, and this is going to become theta over e. And obviously the integration constant c. And just like this, if I show you the integration of this thing by applying this formula, it's simply going to become ln of x by 5 plus 1 divided by 1 by 5. So this 5 goes on the top, right, from here. And that is your final answer. So this is the integration on the left hand side, and this is the integration for the right hand side. So now let me show you how exactly I've done this so that you can understand how to write it in the examination. So that is how it's going to look like in the examination. On the left hand side, I'm just integrating the left side. On the right hand side, I'm integrating the right hand side. And this is the final expression that you will be obtaining in terms of c, theta, and x. But now, how do you find c? As I mentioned earlier, that we are going to use this condition of x is equal to 5 and theta is equal to 0. So if I substitute the values of theta is equal to 0 over here and over here, both the terms gets eliminated to 0. So my c just equals to this term, where if I keep my x is equal to 5, this becomes 5 ln 2. And therefore from here I can say that my c is equals to 5 ln 2. And after that, I just need to make this x the subject of formula. And here is one of the part where students lose a lot of marks because they are either not good with the logarithmic rules or they are not good with the algebra. So regardless of that, just make sure that both of these things are pretty solid for you. Only in that case, you will be able to solve this question completely after this step. So yeah, let me show you the process of how I have made x subject of formula over here. So to start with, I'm just replacing my c with the phi ln2 and taking a common denominator for this step. You can see that I've multiplied this 8 with the theta and this 2 with the sine 4 theta so that the denominator becomes 16. After that, I'm taking my phi ln2 on the left hand side and then I'm using this rule of ln of a minus ln of b is going to be equal to ln of a by b. And then if there is a phi which is constant, I can just take phi as a common and it can be a constant outside this thing. So by implementing this, you can see that x by 5 plus 1 divided by 2 will be x by 10 plus half. So that is how I get this term just by taking this to the left hand side. And this term is staying as it is. After this, I'm going to send this 5 to the right hand side with the 16 so that it's going to become, let me show you this. That's the only one change I have done over here. It's going to become 80. And then to remove the ln, I'm going to have e as the base on both the sides. So that I'm going to left with x by 10 plus half is equals to e to the power of the whole term over here. As you can see that I'm going to multiply my 80 inside the bracket so that I get theta over 10 minus uh, 1 by 40 sine of 4 theta. And after that, I'm going to send my half to the right hand side and then also going to multiply 10 on both the sides. And therefore, over here, if I can show you my final expression, it's going to be something like this, which is absolutely correct. You can see that this 10 is going to be multiplied over here. And then because my this half goes to the right hand side, it becomes minus half, to which if I multiply 10, I get minus 5. And that is how I'm going to solve this question. And now for the next question, we are having this diagram for which we are having this curve and x values lies in between 0 to pi by 4. And in between that, there is also a point M, which is a stationary point, which is maxima, at which the x coordinate becomes equal to P. And in the first part of this question, we are asked to show that this P satisfies this equation. And because I know that P belongs to the x coordinate of the stationary point, how do I solve this? The first step would be to find the gradient function of this given curve. That is simply dy dx. And then at this point, that is the maxima, I know that the gradient becomes 0. So I'm going to equate the derivative of y is equal to 0. And after that, because I know that at this point x also equals to p, I'm going to substitute my x equal to p and then just make p the subject of formula such that I get this expression. So let me show you how I've done it over here. To start with, because I know that the equation of the curve has two terms multiplied with each other, to get its derivative, I know that I need to use product rule. And in applying my product rule, first of all, I'm going to keep my cos 2x as it is and multiply that with the derivative of the x cube, which is 3x squared. And then I'm going to add this with keeping the x cube as it is and multiply that with the derivative of the cos 2x, which is minus 2 sine 2x. That is how I get the second term. Once I'm having this gradient function for this given curve, I know that at point m, where x is equal to p, my dy dx also equals to 0. I'm going to exactly substitute that in the next step, as you can see over here. And because I can see that x square is a common factor over here and x is equals to p, so I'm going to get this particular expression is equal to 0. And then I can say that p square is equal to 0 or this bracket is equal to 0. From the diagram, clearly we can see that p does not equal to 0. So it's safe to say that we can ignore the first part and just focus on the second equation, which is left with us. And now from here, I'll need to think that how can I get 10 to p from the cos to p and sine to p. So just by using the formulas in AS level, that sine to p divided by cos to p is equals to 10 to p. Over here, I'm first of all sending this part to the right hand side and then dividing both the sides with cos 2p so that I'm able to get 10 to p is equals to 3 over this 2p. And then because I need to make this p the subject of formula, I'm first going to take the 10 inverse and then divide both the sides with 2 so that I'm going to left with p is equals to half times 10 inverse of 3 by 2p, which is asked in the question. So yes, that is how you do the first part. And now in the second part, we are asked to show by calculation that the value of p must lie in between 0.5 and 0.7. Now this is a pretty repetitive question that we get from the topic of numerical solutions of a given equation. So the first step that we do over here is we either send p to the right hand side or send the entire right hand side to the left hand side and say that it's equal to 0. And say that whatever is we have transferred to one side is a particular function of p. Once we say that, it's going to be in this particular format, that f of p is equal to 0, which means that if we are trying to find the value of p when this function is equal to 0, we are trying to find the root. And root basically means that when the function is equal to 0, let's say over here it is 0, if 0.5 is over here and 0.7 is over here, let's say if at 0.5 we got a positive value and at 0.7 we got a negative value, so there will be a point at which a function will be equal to 0, and that is the value of p. It could be that let's say 0.5, at 0.5 the function is negative and then at 0.7 the function is positive. Still over here we can see that there will be a point in between 0.5 and 0.7 where the function will be equal to 0. So yeah, this is a very classical question that we get from the topic of numerical solutions, as I explained earlier. So let's see how to solve this kind of questions. So if I just scroll down and scroll this part over here, you can see that I've transferred this p to the right hand side and say that it's a function of p is equal to that. And then if I put the value of p as 0.5, I got a positive value. If I put a value of 0.7 as p, I got a negative value. Now, because there is a change in sign, I'm going to have the final conclusion that the value of p must lie in between 0.5 and 0.7. You can pause the video and read how I have written down the conclusion. You can write it similarly in your own words. And now moving on to the final part, over here we're asked to use the iterative formula based on the equation that we have achieved in the first part, that is this equation, and also use the fact from the second part that p must lie in between 0.5 and 0.7 to calculate the value of p correct to 3 decimal places, giving the results of each iterations correct to 5 decimal places. Again, a very basic question that we get from this chapter. So we're going to start with the iterative formula that is given to us in the first part and substitute the value of p. The first value of p is 0.6 because 0.6 exactly lies in between 0.5 and 0.7. And then I'm just going to use my calculator. In my calculator, I'm going to say that 0.6 is equal to, so that I can store my 0.6 in the variable of a and s in the calculator, right? After that, I'll just keep on pressing equal to equal to equal to get new values of p until it starts recurring itself correct to 3 decimal places. And that is where I'll say that, okay, yeah, that is my final answer. So yeah, to start with, I'm going to say that my p will be equal to 0.6. And then I'll be just using my calc and say that half into 10 inverse of 3 by 2 times answer. Remember that in the answer, we already stored 0.60000. So if you press equal to sign, you will get a new value that is 0.59514 correct to 5 decimal places. Then again press equal to sign, you will get a new value that is going to be this. And you keep on doing this process until you start there is a repetition for correct to 3 decimal places. And therefore you can say that my final answer correct to 3 decimal places will be 0.596. And for the first two iterations, I've just shown the steps, and after that, you can just keep on writing the values. So yes, that is how you solve the final part of this question. Now for the eighth question, we are having two lines of equations in terms of vector format. We are having the first equation, the second equation of the line. And then in the first part, we're asked to show that the lines are skewed. Skew line basically means that they are not parallel to each other and they never intersect at a particular point. Rather, it's just that there are two lines on top of each other. So that is why you don't have any kind of intersecting point, and even they are not parallel. So whenever we are asked this kind of question, the first thing that we prove is that the lines are not parallel. And the second thing that you need to prove is I'm going to equate my x coordinates with the x coordinate, y with y, z with z, then find the value of lambda and mu and say that there are no common point of intersections. And then because neither they are parallel nor intersecting, it means that the lines are skewed. So let me show you how I have done this. So the first thing I'm checking is if the lines are parallel or not. I can do this just by checking if the direction vectors from both the equations are having a common factor. Clearly, I can see that there is no common factor over here. Therefore, the lines are not parallel. The second thing I'm going to check is if the lines are intersecting or not. And therefore, I'm going to intersect my x coordinate with the x coordinate, y coordinate with the y coordinate, and the z with the z. In doing this, I'm going to get three different equations. And from the third equation, you can literally choose any two equations, make the substitutions, find a particular value of either the lambda and mu. And the equation which you have not used, use that to say that if the left hand side equals to right hand side. That is the common process. We know that. So yeah, in this case, what I've done is I've used the third equation to make mu the subject, and then I'm going to substitute that in the first equation in order to find lambda in the first place. So if I can show it to you, the value of lambda I'm getting is 6. And then if I put my lambda is equal to 6 in this expression, I'm going to get my mu is equals to minus 9. And now that I know that I haven't used the second equation, I'm going to put my lambda on the left hand side and the mu on the right hand side. and see that if my y coordinates are equal to each other or not. And in doing this process, if I can show it to you over here, I can see that the y coordinates are not equal to each other, because of which, as the lines are not parallel nor intersecting, it means that line must be skew. And that is how we do this particular part. And now for the second part, we are asked to find the obtuse angle between the directions of the two lines. Clearly, I know that the lines that we are having from part A are not intersecting. It means that over here the lines are on top of each other. Now for the directions of both the lines, we are trying to find out what is the obtuse angle between these directions. So I've just given a rough diagram over here. This is the direction of coming from the first line, the direction vector coming from the second line over here. The first angle I can see over here is an acute angle. And this is the obtuse angle. There are two possibilities of the angles that I can form in the intersecting lines. So to find the obtuse angle, what I can do is I can first of all find my acute angle and then do the total of 180 minus the acute angle from it so that I can get this obtuse angle. So how do I find this acute angle first of all? There is a formula that cos of the acute angle is always equals to the modulus of the dot product of the directions of the two vectors divided by the magnitude of both of the directions. And if you will be able to do this, you will be able to find out the value of theta, which will be acute. And then to find the obtuse angle, just do 180 minus that. So yeah, keeping this idea in our brain, let me show you how I've done this. So I've copied the direction vector from the first part, that is uh, 2, 3, minus 1 from the first line, and minus 1, minus 2, and 1 from the second line. I'm taking the dot product on the top, and then I'm taking the magnitudes of both the direction vectors in the bottom. So I've simply done 2 square plus 3 square plus minus 1 square, that is going to be root 14, and over here it will be root 6. And in solving this further, I'm going to get, because it's a modulus, so even if the answer is negative, I'll need to convert it to positive. So over here I'm going to get cos theta is equals to 3 root 21 over 14. And then if I try to find the angle, I'm going to get 10.893 as the angle. Now because this is an acute angle, to find the obtuse angle, we know that we do 180 minus this. I've also given a rough diagram explanation over here. And therefore the final obtuse angle that I'll be having between the directions of the two lines will be coming out to be 169.1. Now for the ninth question, we are having a polynomial which is denoted by b of x, where this a and b are constants. It is given that x minus 3 will be the factor of this polynomial, where the first derivative of this polynomial when divided by x minus 3, the remainder is 72. We are asked to find out the values of a and b, again a very repetitive question. What I'm going to do is I'm going to use factor theorem and the remainder theorem to solve this. So the factor theorem is going to state that if I put my x equal to 3 in this polynomial, the output of this polynomial will be equal to 0. That is how I will be getting my first equation. Then for the second equation, I'm going to first of all take the derivative of the given polynomial. And now if I substitute x is equal to 3, the output of the derivative will be equal to 72. That is how I'll be getting the second equation. Now that I'm having my first equation and the second equation with the two unknowns, I can just solve them together to find the unknowns of a and b. So let me show you how I have done it over here. So here is my polynomial and the respective derivative. Just by using the power rule, I can get the derivative. And then from the polynomial, if I put the x equal to 3, I am going to get the first equation because polynomial of x equal to 3 will be equal to 0. So that's my first equation. The second equation is coming just by putting x equal to 3 in the derivative equation. And then I'm just solving them together and getting the values of a and b over here, as if I can show it to you, as minus 11 and minus 24. From the second equation, I've just taken b, the subject of formula, then substituting that in the first equation. From here, I got a is equals to minus 11. Then putting this minus 11 in this equation, I'll be getting b as minus 24. So yes, that is how I solved the first part. Now for part b, we are asked that when a and b are having the values that we found out in the first part, we have to factorize p of x completely, which means that I'm going to utilize these values of a and b that I found over here, put it back into this polynomial, and then because I already know that x minus 3 is a factor of this cubic polynomial, I'll need to figure out what is that another quadratic factor that I can multiply with my x minus 3 to get my polynomial of p of x. So in order to do this, there are two different ways. The first way is with the help of long division. I take my polynomial, divide that with the factor which is x minus 3 and get a quotient. A quotient will be a quadratic factor in terms of ax square plus bx plus c. So if you're able to find this, obviously the remainder will be equal to 0 because this is the factor through which you are dividing your polynomial. This is your quadratic factor. Once you are having your quadratic factor, you can further go ahead and try to factorize it in terms of linear factors. And then that is how we say that we have completely factorized the given polynomial. You can also, by the way, do this question with the help of inspection technique, where you say that x minus 3 multiplied with this ax square plus bx plus c is equal to polynomial. And then over here, you just compare the left hand side with the right hand side to find out the values of a, b, c. And then you can take this quadratic factor and convert that further into linear factors if possible. So regardless of any technique that you are familiar with, you can go with that. But now let me show you what I have done for this part. So as you can see guys, I have used long division technique over here. I am assuming you guys are well versed with how to do the long division because yeah, it's a very basic thing that we do in P3. And let's say if you're not well versed with this, you can also go with the inspection technique. Regardless of that, we'll be ending up getting a quadratic factor being 6x squared plus 7x minus 3. In case of any kind of doubts over here, let me know in the comments. I'll be very happy to help you out over there. So now I can say that this polynomial can be expressed in the linear factor of x minus 3 multiplied with the quadratic factor, which is this. Now the question is, can I further convert this into two more linear factors? I'm going to take out my calci and see that if it's possible. And I saw that yes, it is indeed possible. And I got two values from the calculator. One is 1 by 3 and the other one is minus 3 by 2. So from the 1 by 3, I got this the factor. From minus 3 by 2, I got this the factor. And finally, I can say that I can completely factorize my given polynomial into this particular view. So yes, that is how you solve this question. And now for the final part, because they have used the word hence, it means that I'll need to use something from my previous part in order to solve this inequality, where I can say that my polynomial is less than 0. Or in simple terms, find those values of x where my polynomial will be under the x-axis. That is, where my y values will be negative. So how can I do this? Now for the students who are good with drawing the cubic graphs just by looking at the factors, this question can be solved under 10 to 15 seconds. For the students who doesn't know how to utilize these factors to sketch a quick graph of the cubic equation, and then from utilizing the cubic equation, you can directly find out the inequality, then it's going to be a bit challenging for you. So yeah, let me show you how I have done it over here. So the first thing that I've done over here is I have marked my axis, and on the x-axis, I have marked the solutions of the roots of this given equation. So from the factors, we know that we can easily find out the roots. From x minus 3, I got 3 as the root. From this, I got 1 by 3 as the root. And from the last one, I got minus 3 by 2 as the root. And then because I know that from the cubic polynomial, the leading coefficient, that is the coefficient of x cube, is positive, it means that the cubic graph is going to look something like this. If the leading coefficient or the coefficient of x cube was negative, the graph would have looked something like this, right? So I know that my graph is going to look something like this, so I'll be sticking with that. Now having this kind of an idea, if I scroll down, over here, I'm going to start from the bottom part. Then because I know that the second root is over here, I'll need to come down. And then I know that the third root is over here, I'll need to go up. So that is how you sketch a quick graph. I'm not saying it's 100% correct, but still you are having an idea that for what values of x, my graph will be under the x-axis. I can clearly see that for all the values of x that is less than minus 3 by 2, my graph stays under the x-axis, and along with that, in between my positive 1 by 3 and 3, my graph stays under the x-axis. And therefore, the final solutions over here will be uh, x is less than minus 3 by 2, and along with that, x is also in between 1 by 3 and 3. So now for the 10th question, we are given a function, and the first part we are asked to convert this function into its partial fraction format. So now because in the denominator of this fraction we are having a linear term and a quadratic term, so it's going to be expanded in the partial fraction in this format, and also because it's a proper fraction, so we don't have any plus d extra on top of this. So now the second step would be to just go ahead and make a common denominator. So I can do this just by multiplying my 4 plus x square with a and 1 plus x with bx plus c. So now I know that the denominator part are just going to be equal to each other. So now I'm going to compare only the numerator part. And therefore, in doing so, I'm going to get minus 7x square plus 2x minus 6 is equivalent to a times 4 plus x square plus bx plus c times 1 plus x. Now after this, I just have to compare the x square term with the minus 7, x term with the 2, and the constant with negative 6, out of which I'll be getting three different equations. Let me show you how am I going to do this. There we go. I have done an extra step over here so that I can find out what is the coefficient of x square on the right hand side, what is the coefficient of x, and then what is the constant. Once I'm done with that, I am saying that minus 7 is equals to a plus b, that is the first equation. The second equation is b plus c is equals to 2. And then the last equation is 4a plus c is equals to negative 6. Now from the second equation, as you can see, I have made b the subject of formula. Now I'm going to just substitute this b in the first equation so that I can have an equation in terms of a and c. And even in the last equation, we are having an equation in terms of a and c. We can solve both of this equation together. That's the whole idea. So after substituting this b in the equation 1, I'm going to get a is equals to c minus 9. And now I'm going to substitute this a in this equation and I'm going to solve for c. So first of all, by substituting this a in this equation, I got the value of c as 6. Once I'm having my equation of c or the value of c, I'm going to substitute that in the equation of a to get the value of a. So 6 minus 9 is minus 3. That is how I get a is equals to negative 3. Similarly, I also have an equation for b. So I'm going to substitute the value of c of 6 in this equation. So 2 minus 6, as you can see, is going to become minus 4. So now that I'm having the values of a, b, and c, I can say that my final partial fraction format of the given function will be minus 3 by 1 plus x plus 6 minus 4x over 4 plus x squared. That is how we solve the first part of this question. And now for the last part, we are asked to find the exact value of the function, or I should say the integration of the function from 0 to 2, giving our final answer in the format of a pi minus ln b, where a and b are both the constants. So now I know that because I have expressed my function in the format of a partial fraction, I can easily integrate. And that is what I have copied from the previous step, and I mean the previous part, and I'm starting to integrate both the sides. On the left hand side, it's pretty straightforward. 1 by ax plus b, again it's in the format. And on the right hand side, what I'm going to do is I'm going to distribute my 4 plus x square for both the terms. So it's going to become 6 by 4 plus x square and then minus 4x over 4 plus x square. The reason behind doing this is, for the first part, when I'm going to get 6 over 4 plus x square, I can use the equation of integration of 1 by a square plus x square. So over there I can use the tan inverse formula. And then for the second term, minus 4x over 4 plus x square. For this part, I can use the reverse chain rule basically, where ln of the bottom part is what I'm going to get. So yeah, let me show you how I'm going to do this. So for the equation on the left side, or for the term on the left side which I'm integrating, it's simply going to become ln of 1 plus x, and then I can divide this with the derivative of the inside function, which is 1. So division of 1 is just the same thing, so that's why I'm not showing that. And there is also minus 3 over here, so minus 3 ln 1 plus x is just the integration result of this term. Then over here you can see that I've expanded this function into two different derivatives. And then over here now, because I'm having 6 over 4 plus x square, I can take 6 out as a constant. I'm left with 1 by 4 plus x square. That is 1 by 2 square plus x square. And then according to the formula given in the MF19 booklet for this one, we are going to get 1 by a, that is 1 by 2, tan inverse of x by a, which is tan inverse of x by 2. And obviously because 6 was out in the constant, that is carried forward over here. And then for this term, I'm applying the ln of the bottom part rule over here. But for that, I need to have my f dash x on the top of the function in the bottom. So if I take the derivative of the bottom part, I'm going to get 2x, not 4x. So in order to make the top part as 2 instead of 4, I need to divide my 4 with 2. So if I'm dividing this equation by 2, I also need to multiply by 2. And that is where I'm getting this 2 by 2. So the bottom 2 is going to get cut with this 4 to become 2x. And therefore it's going to become 2x over 4 plus x square. And now because the derivative of the x square is 2x, so I'm just left with the final integration of this result as 2 ln 4 plus x square. After this, I just need to substitute the values of the limits, and that's it. I'll be done with this integration. Over here, I'm going to express first of all 2 inside the values of x, and lastly the 0. So whenever I'm going to put 2, it's going to become minus ln 3. Over here 6 by 2 is 3. Tan inverse of 2 by 2 is 1. Minus 2 ln 4 plus 4 is 8. So minus 2 ln 8. And then if I put 0 over here, ln of 1 is 0. So that is going to be cancelled out. Tan inverse of 0 is 0. So even this is cancelled out. So I'm just left with minus of minus 2 ln of 4. After this, because I know that in my final expression, I just want minus of ln of b, where b does not have any kind of power, ln does not have any kind of coefficient, it just has negative 1 outside, and pi should be in front. So based on this knowledge, I know that I'll need to take this 3 pi by 4 which I'm getting by solving this part. This will be on the front. And for the remaining part, because I know that minus is something that I want, so I'll take this 3 as a power of this 3. I'll take this 2 as the power of this 8. And I'll take this 2 as the power of this 4. So that I'm not having any extra coefficients outside. And then I'll just take minus as a common factor and then see what I'm going to be left with. So over here, that's exactly what I'm doing. Minus ln 3 cube minus ln 8 square plus ln 4 square plus 3 pi by 4. And now because I want this pi term on the front, so I'm going to take this in the front. And then I'm taking the minus sign in the common because in the question itself, we wanted a minus sign in front of ln. And then I'm just clubbing out the stuff over here. So because this and this has minus common, so ln cube, I mean ln 3 cube plus ln 8 square will be clubbed together. And then instead of plus ln 4 square, we are going to have minus ln 4 square, so that this minus and this minus, once the bracket is open, we get plus. And in doing this process, I'm finally left with just a simplification of this ln terms. Over here, I'm using ln a plus ln b, that is going to be ln a into b. And then we are also having minus of ln c, that will be going in the division. And finally, I'll be left with, if I use my calci, 3 cube into 8 square by 4 square, I'll be getting 108. So the final answer of the integration of the given function between 0 to 2 will be equal to 3 pi by 4 minus ln of 108. So yes guys, that is how we solve this. And now for the final question, we are asked to find the exact value of the integral of x square into cos of x by 3 with respect to x, and the limits are from 0 to pi. And now because we are having two terms being multiplied and we are trying to integrate this time, so we are going to use integration by parts whose formula is written over here. And now according to the integration by parts formula, we'll need to decide which term is u, which term is v. So in the late rule, a comes first, p comes later. It means that the algebraic term is u and the trigonometric term is v. And then according to the formula, I can say that I need the values for, or I should say, I need the expressions for the integral of v and also the derivative of u. And therefore, I've also taken the derivative of u over here and the integral of v. And then simply implementing this formula, I'm going to have the integration of the given term is equals to u times integration of v. So x square into 3 times sine of x by 3 is written over here. Then minus integration of u dash into integral of v. So 2x into 3 times sine of x by 3. So that is how I got this term. After this, I can see that there is one more integration sign on the right hand side which I'll need to think about. So again, because there are two terms multiplied with each other, one is algebraic and one is trigonometric, very similar to this one, I can again implement my integration by parts rule, where u will be equal to x and v will be equal to sine of x by 3. And then if I just delete this now and take this a bit down, you can see that 6x is u and v is equals to sine of x by 3. And then according to the formula, I need u dash and integration of v. So the derivative of 6s is 6 and the integral of v is going to become minus 3 cos of x by 3. Substituting this using the formula of integration by parts, the first part is going to stay as it is, there is no changes over here, but then there is this negative sign being carried forward, and I'm going to simply multiply my u with the integral of v to get this term, and then minus of integration of u dash into integral of v. And now I can see that I can easily integrate this because integration of cos does not require any kind of integration by parts. And therefore, everything else from the top part comes as it is. Only this part is getting changed. And the integration of cos of x by 3 will simply be what we have written over here. As you can see, 3 times sine of x by 3. And then that's it. We just need to implement our limits and we will be getting our final answer for this question. And because we are asked to write the answer in the exact format, please make sure you are not using any kind of decimals over here. So substituting pi, I'm going to get 3 pi square into root 3 by 2 plus 18 pi times half and then minus 54 root 3 by 2. And if I put 0 over here in all the terms, I'm going to get 0 because sine of 0 is 0. Over here also sine of 0 is 0. And because 18 is multiplied with x over here, so even this term becomes 0. That is why when I put pi, I get 3 terms. When I put 0, I get just 0 everywhere. And then I can just simplify the root 3 by 2 terms over here by saying that 3 pi square minus 54 is going to be inside the bracket if we take root 3 by 2 as a common factor. And then I'll be left with 9 pi over here. So yeah, depending on how you want to simplify it, you can go it further after this step. But the final answer that I've written over here is 3 root 3 by 2 times pi square plus 9 pi minus 27 root 3. So yes guys, depending on if you want to leave your answer over here, even that is fine. If you want to simplify it even further, even that is fine. But yeah, that's all we are going to get for this particular question. So thank you so much guys for watching this video so far. And I hope that this has helped you. In case of any kind of doubts, let me know in the comments and I'll be there to help you as much as possible. And then if you want any kind of one-to-one coaching to boost up your grade, you can reach out to me on this WhatsApp number and we can have a chat and discuss about how we can go further. Thank you so much, guys.